In this video, your instructor is going to be walking you through the particle system. There are a few changes to be aware of, and I'll be sure to highlight these for you as the video plays. To follow along and create a particle system, you go to Game Object, Effects, Particle System. Enjoy learning about the particle system. I'll see you towards the end, and remember to listen for this sound.
Particle systems in games differ significantly from particle systems for film, visual effects, broadcast television, and advertising, for example. I've made a new scene here in my Zombie Toys Unity project, and I'll take a quick look at a particle system, looking at some of the features of it, and we'll compare and contrast between game particles and visual effects. I'll make a new particle system by choosing Game Object and Particle System, and there's a default Unity particle system, puffing out fuzzy white balls from a central point. What we're seeing here is that these are sprites, that as I go around them, they appear to be facing me at all times. Particles in games, then, are typically points in space that look like something, not volumetric objects. The other big thing with particles in games is that they're created and rendered in real time, and they have to behave that way. We don't want to be walking around our game and see the rain lag, for example. Now, one of the things that's similar between game particles and visual effects particles is the depth in the controls. We'll get a lot deeper into our particle systems, but we can see very readily on the surface that we've got control over duration. How long do they last? We've got control over their lifetime and speed, their start size, their rotation. We've got control over their start color and a gravity modifier. What space are they simulating, world or local, and so on. As we scroll down, we'll see we have a lot of control over the emission. How many of them are we dealing in, and are they coming in bursts? We have control over the shape. Where are they coming from? In this case, a cone. Further down, we can see a lot of different menus available. Looking at things like velocity over lifetime. Do they slow down over their life? Force over lifetime. Are they blown by wind? And color. Do they go from black up to gray like smoke? Do they have a size over lifetime, expanding out, or maybe contracting and disappearing? We can even deal with things like rotation. Do they spin, or do they slow down to a stop? And external forces and collisions. Are they colliding with things in our scene or planes? We'll also see even that we can use animated materials in here, or rather texture sheets. We can bring in a sequence of images or frames or an animation and map them on particles and make birds flying around, for example. We're really only limited by our imagination and by that constraint of needing to show in real time. Now, by default, these are sprites, and so the cool thing about them is that we can gang together a bunch of different particle systems to make what looks like a very complex effect. In reality, we'll have a bunch of simple particle systems that together produce an overall rich effect. I'll jump into Autodesk Maya and take a quick look at a particle system there to compare and contrast visual effects particles and game particles.
There are a number of changes between Unity 5.6 and the latest Unity 2017. A lot of the change has to do with system improvements. For example, the Unity particle system now supports sprites for 2D games via the texture sheet animation module. Particle collision forces have also been added, which can actually move objects with colliders. Additional shapes have been added as well, such as a donut shape to help you quickly create your desired effect. Lastly, Unity 2017 introduces a new noise module so that you can customize how your particles are emitting. Previously, you could only add noise to the particle positions. Now you have the flexibility to apply noise to the position, rotations, sizes, and even your shaders using new custom vertex streams, which will allow you to get a really cool UV distortion effect. With these new improvements to the Unity particle system, you can create complex and innovative particle effects like never before. I'm going to hand you back over to your instructor now so that you can see a live demonstration between game particles and film particles.
I'm here in Autodesk Maya, and I've created a very simple particle system to illustrate some of the differences between game particles and film and visual effects particles. What we can see here is that I've got a stream of ping pong balls or golf balls pouring out of a place in space, impacting a gray plane, running down that slope onto the ground on the grid, or at least down to a plane we can see there. One of the biggest things that separates film particles or visual effects particles from game is we have the ability in visual effects particles to work in volumes and have a lot of self-collision with the outside of the mesh. Now, both particle systems can collide with objects in the scene. However, what we're seeing here is that these are not only colliding with themselves, they're bouncing off those objects and colliding yet again. In a pre-rendered system, we can do this, or in a cached system, where we calculate these particles ahead of time. In games, it has to work real time, and that's the huge separation. Now we see a lot of the same controls. How big are these particles? What are they doing? Are they sticky? Do they bounce? We have these same kind of controls in games. We're seeing properties in here like shading. We're seeing things like rotation. Are they affected by force fields, gravity, and so on? Where we really see them differ is when we get into things like the particle type. We have options in here for spheres, for multipoints, for streaks, and so on. We can even blob things together, and that's where this really starts to separate. A blobby surface showing a smooth outside shell, or at least reasonably so, is difficult in a game. But here in a pre-calculated particle, we can do this. We're seeing a lot of similar controls in the emitter as well. Where is it? How fast are they coming out? How is it spreading out? Analogous to our cone or sphere or whatever emitter we're using here in Unity. In Maya, we're seeing something similar. We can make them spread out, we can randomize their speed, and so forth. And we're seeing a lot of similarities in the controls, even if the names are a bit different. The big difference, though, is the particles themselves. How big are they on their outside, and what are they reacting with? Now, the design constraint this puts on us is also, where are we seeing these from? Let me say that again. In games, we can stand back and look at our particles, and they look great. But when we get right in the middle of it, we have to make sure that our particles behave properly. Here in a visual effects simulation, if we choose, let's say, elephants for our particles, we can be standing in a stream of elephants, and that's where this really differs. If you're pre-calculating, you have a lot more latitude. If you're dealing in games, you might see simpler systems lumped together that look very complex, but actually aren't a volumetric object at all. So keep those things in mind. It really comes down to rendering in real time, and game particle systems are made to do that. Visual effects particle systems are not.